Session, Transforming Future of Microbiology, Perspective of Next Generation. This session will be moderated by Dr. Sushma Pednekar. Dr. Sushma Pednekar is an associate professor at BJ Government Medical College and Sassoon General Hospitals, Pune. With 14 years of expertise in diagnostic microbiology and 10 years of focused work in hospital infection control. She has extensive experience in nosocomial infection surveillance, antibiotic policy development, and infection control training for healthcare workers. She has managed NABL accredited laboratory operations and led COVID-19 diagnostic efforts, including RT-PCR and Gen expert testing, as well as investigations into COVID-associated mucormycosis. Dr. Pednekar has 12 national and international publications in a recognized journals, and she has a postgraduate guide also. She has received multiple awards, including MedWorld Asia International Excellence Award in Medical Education. Additionally, she has conducted state-level training programs in infection control and COVID-19 preparedness. She is also in charge of scientific committee of this conference. I will hand over mic to Dr. Sushma Pednekar to start the session.
पूर्णपणे बरं का प्रश्न मला थोडं पण कमी जास्त नसेल आता तिकडे बोलताना तुला सांगितलं बोलताना इकडे
Thank you, Dr. Vaishali. Generations are changing fast with technology in today's world. It will be appropriate that we give new generations a chance to express their ideas, and this will be an opportunity for us to understand their perspectives. With this, I call upon our first speaker, Dr. Akshay Karyakarte. He is a clinical microbiologist with close to 8 years of experience holding an MD DMB in microbiology. He currently serves as assistant professor at St. GS Medical College at KM Hospital, Mumbai, as a supervisor in the clinical bacteriology laboratory. Additionally, he is actively involved in infection prevention and control activities, undergraduate, postgraduate teaching, and coordination of interdisciplinary clinical services. With a keen eye for research, he has numerous peer-reviewed articles in international journals and many more in pipeline. He also serves as a certified peer reviewer for esteemed publications like the British Medical Journals, among many others. Always on the look out for scientific improvement, he is constantly dabbling in cutting-edge technologies, whether it be getting certified in CRISPR, gas gene editing applications from Harvard University, or being a key supervisor for the multi-top MS machine installed at the Department of Microbiology at KM Hospital, Mumbai. With this, I am pleased to welcome him to talk about his perspective about multi-top MS technology and its future application. Dr. Akshay.
So good morning to everyone. First of all, thank you ma'am for that very kind introduction. This conference has been an intellectual feast, and I'm truly honored to be standing here and talking upon something which is very close to my heart, that is the mandate of MS. So as regards to perspectives of the next generation and what lies ahead, I would like to first begin with what actually MALDI-TOF is. Everybody knows that, but so MALDI-TOF is an abbreviation which is matrix assisted laser desorption ionization time of flight mass spectrometry. So what it does it is an automated identification system, giving accurate identification for bacteria, fungi, microbacteria in minutes. So the reduction in time in identification of microorganisms and pathogenic organisms is the key why MALDI-TOF MS has been so popular in the recent times. So how it works? So how it works is actually hidden in its name. So matrix assisted. Matrix assisted means the matrix which we are putting upon the microorganism, the pure culture of the microorganism. It converts it into biomolecules which are then inserted into the machine, and a vacuum is generated over there. And in the presence of a vacuum, a laser is bombarded upon that, which makes those particles or those biomolecules ionized. So matrix associated ionization has been done. And addition of an electric field from negative to positive charge makes it helps it to dissolve from the slide which has been. So matrix assisted laser desorption ionization. Now the addition of an electric field makes these molecules, makes these proteins which are inherently negatively charged, rise up from the slide up to the detector. So this is now, of course, the time which is required for the particle or the protein to reach the sensor is defined as a time of flight. This is going to depend upon how much charge it holds and how much mass it has. So this time of flight is a function of mass by charge. So m upon z is the important function over here. And these particles which are reaching the sensor are then read and analyzed by mass spectrometry. So all these together come together and help us identify the proteins, identify the biomolecules which are inside the microorganism. So we can see how it works over here. Right, so how does it identify them? Just breaking down microorganism down into its constituent biomolecules is not sufficient. So what happens is this mass spectrometric analysis produces a spectrum. This spectrum has unique peaks which correspond to the specific mass upon charge ratio, and this is then fed into a database which is specific to those specific vendors which produce that machine. So what mass spectrometric analysis has been obtained by the microorganisms which are being processed on one data, they are going to be compared with this database, and if these peaks match with them, it is going to be identified as so and so organism. So this is how it works. So what has happened in all this is two important things. First important thing is that the time required for identification of these organisms has reduced drastically from hours to minutes. But also most importantly, we require a pure culture for identification of organisms in biodegradability. So the next thing is, so what? What if we are able to identify them in minutes? What happens then? Because if it requires a pure culture, how much time is actually being saved? Because overnight incubation and inoculation of samples, all those processes are not being bypassed. So in effect, what is helping? How is the patient being helped by that? So the answer to that is what is being done right now. What, other than the identification of these pathogenic organisms, what is multi-top MS technology being used for? So it is being used for detection of viral pathogens. Most importantly, in the pandemic, it was used very frequently and very rampantly for the detection of SARS-CoV-2 in a qualitative way, not a quantitative way. Then identification directly from positive blood cultures. This, according to me, is the most significant advancement which has been done with multi-top. And direct detection of AMR is also being practiced right now. We'll handle this one by one. So what's been proven is a Chilean study which was done in 2020, right in the middle of the pandemic. So what happened was, those scientists decided that RT-PCR is taking too long. We want to rapidly identify, isolate, and carry out further epidemiological measures of patients of SARS-CoV-2. Now the challenge they faced was that it did not have those databases or those spectra which are required to identify the organisms. So what they did was they took hundreds and hundreds of known positive and known negative samples, and they prepared a library of their own. That is, they prepared a database of their own, and then running those samples directly from the nasal swab onto the multi-top slides, they compared those spectra which were obtained to those libraries that they generated themselves. So, detection of SARS-CoV-2 in patients' nasopharyngeal swabs was reduced from hours to minutes. So that was one very big advantage of multi-top in those situations. Next thing, probably the most important aspect of multi-top MS and its application to actual patient management was identification of identification of microorganisms from positive blood cultures. So these positive blood cultures which are flashed positive, they are not directly going to be put on the multi-dose machine of the slide. It may not get detected. They might be false negative. So what they did was, they did two things. First was saponification, next is centrifugation. So they did those particular things in order to obtain something known as a microbial pellet. And this pellet was considered to be the actual pure culture and then loaded onto the microbiology machine. So what happened was, the moment these blood culture bottles flashed as positive, immediately they were saponified, centrifuged and tested on monitor. And the identification was obtained in minutes rather than overnight on the next day. So how it helped was, they were obtaining the identification of the organism in the blood culture it will help the clinicians to change, to de-escalate and actually stop the use of empirical antibiotics. So empirical antibiotics in blood cultures, as we all know, are usually higher antibiotics which are used. So de-escalation can be initiated early. If required, the antibiotics can be stopped early. So this paves the way towards actually reducing AMR in hospital settings. So this is a very, very, very important part in which multi-drug can help the clinician. Now, another thing which is being done right now, not at a grand scale of course, but it is being done right now, is actually intersectoral coordination between microbiologists and engineers, or software engineers to be specific. So what they did was, in Taiwan, what they did was they developed a